Hello, hello. Welcome to Enlightning. I'm Whitney Lee, and this is my illustrious guest, Tim Berglund. Thanks for joining today.
Thank you for having me, Whitney, and good morning. I'm going to just be entirely parochial since you're in Central Time, I'm in Mountain Time. It's morning for both of us. Wherever you're watching, it might not be morning, but good morning, Whitney.
Good morning. Thank you. Good morning, Tim. We have some love in the chat already. If you're here, please say hi. Hi, Cora. So good to see you. Hello, Abhishek. Welcome back. Thanks for coming. Tim, we met recently at a conference because we were both speaking there. Yes. And I recognized you immediately because if you Google what is Kafka, two videos come up, one with my mug and the other with yours. And I'm just like, hey, that's the what is Kafka guy. What's up? So I think I was weirdly
the other Kafka lightboarder.
Yeah, we're a special breed, the lightboarders. I think I was weirdly too friendly to you in a way where I felt like I knew you from seeing you on a screen. You know how that goes?
And if you're a person who's on screens, you know that happens all the time.
So we have more love in the chat. Hi, Napalm. Welcome back. So good to see you. And Rick's here. Rick's a past guest on the show. And he's my mentor from IBM. So happy to see you, Rick. You're wonderful. I'm so glad you're here. So Tim, you have some really cool stuff going on in the background. Can you tell us more about it? I feel like your background's a self-portrait of sorts.
You have no idea. So the books, and it's a little bit, I can actually adjust the focus, so we can rack focus to back there while we talk about it. Move the microphone out of the way a little bit.
Here, maybe I'll make you bigger on the screen too.
Okay. You made me smaller. There we are. Okay. So there we are. This is the microphone is a problem. I got like a little computer history museum going on over here.
Cool.
This is the motherboard from the first PC I owned in the early 90s. It's a 386 SX. It was actually a 286-12. I upgraded it to the SX16. If you know, you know. There's an old vacuum tube there. That's a ST225. My fellow old timers, that is an old Seagate 20 megabyte MFM hard drive. I am not old enough to have used 8-inch floppies, but there you go. And there's like stuff back there. This is just an old crappy Windows laptop. This is a Macintosh SE, and it still does boot up if you plug a SCSI drive in the back. It absolutely boots.
That Macintosh is totally what I had at home. We had music software.
Mm-hmm. Books from college and stuff like that. And this is it's hard to point when it's reversed. Here we are, the hardware hacking bench.
Cool. Nice. When the hardware hacking bench was out of focus, I thought it was it reminded me of a card catalog from library when I was
So you don't have to be as old to remember a card catalog as you do to know what an ST225 is. But, it's people of a certain age, right?
I only recently got into tech, so most of what you're saying honestly just sounds like letters and numbers to me, but you're saying them so confidently that I feel
that's the key.
I really it helps you feel important. We have Rick says, I just watched Tim's talk from Debug Poland last night and it was awesome. What did you talk about in Poland?
Well, that's an embarrassing question, Whitney, because I can't remember. It was literally a difficult time in my life last August, and I don't remember what the talk was about. I can't believe it. Rick, I wonder if you might put... I'm sitting here blushing. I wonder if you could just put in the chat. What was I talking about in Poland? It was such a bad week. DevOps Poland is amazing. Grzegorz Duda, the organizer, amazing person to work with. I'm going to be back there in 2 weeks. Love that guy. Love that city, Krakow. I'm going to be talking about Pinot in 2 weeks. But yeah, I forget what I was talking about. Something about Kafka. 5 things that go wrong in event-driven architecture. Yes, that's right. That was such a good talk. Thank you, Rick. Man, it was good.
He has your back.
Memorable. Definitely a memorable talk.
And then Nick, the first one, says, hi, how's it going, Nick? You come to almost every stream. I appreciate that so much. And Nick says, oh, floppy disk, so nice. That's Yeah, I don't remember an 8-inch. I remember like a 5-inch maybe. I definitely remember
those were more late 70s. They were not super popular even by the early 80s. It was 5 1/4 was standard by the early 80s, and then the 3.5s. That in the PC world, you had the whole decade of the 80s and really early 90s before the 5 1/4s went away. My first PC had both, but I bought it in 91. It had a 5 1/4 and a 3.5.
Nice.
That was standard then. So
when we hung out in Atlanta, we talked a little bit because I talked to you about how I felt intimidated coming into this field. Like I feel so bright-eyed and bushy-tailed, and you clearly have been around computers and been deeply interested in this stuff your whole life. And sometimes it can be it can be intimidating for me, but you made me feel like I belong here, and I appreciate that.
Good. Yeah, I think that's important. I think everybody does, and especially people who are new to the field, people who are tenured in the field, which is a polite way of saying old, but more tenured technology professionals. I think it's their absolute, fairly solemn responsibility to help new people feel welcome, because we're going to wear out, we're going to retire, we're going to die. There need to be new people doing this, and you can make that a painful process. You can make it. You can do a lot of gatekeeping and make people really suffer and feel intimidated, or you can make them feel welcome and like they belong, and their questions are the questions that we had when we were new, or whatever. I think it's just important for tenured tech people to go out of their way to make people feel welcome.
Absolutely. And in any field, really, anytime you know a lot more than someone else about anything, your job, you could choose to be snooty about it, or you could choose to make them feel welcome and teach them.
Yeah,
and so,
exactly.
Yeah. And it's just more fun to lift everyone up.
Napalm 684 just found out the old guy on the team was my birthday. I don't mind announcing this on the live stream. It's my birthday on Wednesday. 50. It's a big one.
Oh, are you doing anything to celebrate?
I am. I'm actually going to be at Star Tree headquarters in Mountain View, and yes.
It's just yes. You're not going to share exactly what it is. I respect it.
Yeah. So that's probably just a happy hour, friends.
Nice. That's lovely. Cora says congratulations. We also have a comment from Nick, the first one. You have so many nice topics, and it's always a delight to watch the streams. How can one just not attend? Oh, that's so nice. And we have another happy 50th for you.
Okay, thanks.
Excellent. So you mentioned Star Tree, and you've kind of talked about making people feel welcome. So you are actually, why don't you give yourself an introduction? I know you're titled to be the VP of Developer Relations at Star Tree. Here, I'll put a link in the chat for you. And what does that mean exactly? Your title, and maybe a little bit about you personally, like your history.
Sure. So I think I'll start with that. I obviously have this computing stuff from way back when. I got my first computer when I was 10 and spent the rest of my childhood writing software, and we didn't call it hardware hacking back then, but I did electronic stuff. And I got a computer engineering degree, and I wrote firmware for a while. Then I became a web developer back before we said full stack web developer. That's what I did. And eventually kind of drifted from there into training. I realized, hey, I like teaching and writing curriculum, and I'm good at it. And that kind of led into conference speaking. And around that time, around 10 years ago, there was this kind of coalescing idea. And I think people at Google were using the term DevRel, or developer relations, but it wasn't really a thing, right? But in my last 10 years, professionally, my background as an engineer, the fact that I'm good at teaching stuff, I'm a good communicator, that all kind of coalesced around this idea of developer relations. And if you don't know, developer relations is a team, it's a function, it's a layer in a company where we help the company's technology make sense and seem like a good idea, and we help make it fun, we help make it understandable, we help make it easy to get started with, whatever the subject technology is, right? Anything with a developer-facing surface area can benefit from what DevRel people do. Now, I work for an infrastructure company. StarTree is a company that makes a real-time analytics database. We're going to talk about that today, real-time analytics, and how that fits into event-driven architecture. But that's infrastructure. You mentioned the Kafka video. I spent 4.5 years at Confluent working with the Kafka community. Both of these are infrastructure. They're absolutely worthless to anybody who's not a developer. And I mean, that's an exaggeration. They're both technologies, Pinot and Kafka, that you probably use every day and you really can't avoid. But the only people who use them directly are people who are computer programmers. And so the function of a DevRel team is to talk to those people, the people who actually use it. Because, there's marketing and there's sales and there's investor relations and press public relations and all these other kinds of layers in a company that do very valuable and important things. But we're here saying, the way technology gets adopted is developers fall in love with it and they start building stuff.
And developers, I don't think resonate with the marketing speak, or if you just
no, absolutely not.
You need other developers to tell developers what's cool.
Absolutely not. We either think, oh, you're just not a smart person, or you're not talking to me, or whatever. And here's an interesting test. If you look at startups, early stage startups, their website talks about the technology. And if you don't know what it is, like say you didn't know what Pinot was, you could go to startree.ai, and we're an early stage startup. And so it's talking about the technology, and you'd pretty quickly get an idea what it is. Now, 2-3 years in the future, there will have been growth and maturity and a pivot to where the founding engineers didn't design the website, but the product marketing team will have taken control of the website. It's just what happens, right? And if you look at tech startups at that stage,
interesting.
I, as a technology person, will go to their websites. I am incapable of determining what the technology is. I literally cannot tell. Like, okay, well, here are use cases and benefits and ways it's going to transform my deepest desires of my heart.
I relate to that so much.
What is it? I can't tell. And so, it's not that that's a bad kind of communication, because there are people who write checks. Buyers respond to that. That's why it happens. We build things don't. And so the dev.startree.ai website eternally will speak, as long as there's a StarTree, is going to speak to developers. We're going to say, okay, here's what Pinot is. Here's what our stuff is. This is us. And let me tell you how the technology works, because you're trying to understand it. You're not trying to understand the features and benefits. That's just not, it's not where we go first. People putting thank you everybody for putting startree.ai in the chat. Keep going.
So Steve says hi to you, and we're getting a lot of so true, 100%. Like all the developers totally relate to what you're saying.
Absolutely, and that's why DevRel is a thing. Because final thought.
Okay.
Back when some of this technology back here was current, the way software got adopted was an account executive played golf with a CIO, and they had some drinks, and something got sold, and then developers found out, oh, this is what we're using. It's not how it works. These days, we fall in love with stuff, and then it starts getting used. And then a CIO can buy stuff after we've gotten on board.
That's as it should be. As it should be. And then another question, a question I get often around developer relations is like, how does, as a developer, if you want to get into developer relations, what's a good path for that?
Okay. Wow. We're going to need to talk about event-driven architecture soon, but
okay.
Right. So if you have no experience at all, look for a meetup in a technology area adjacent to what you do. And contact the organizers. Meetups are still mostly virtual, just post-pandemic. That might be true for a long time. But say, hey, I'd like to speak at this meetup. If you're not an expert in every area of the technology, that little voice in the back of your head that says you're not good enough, tell him or her to shut up. It's not true. You'll do fine. Give a talk at a meetup. If you don't want to give a talk at a meetup, write a blog post about something you figured out. If you don't have a blog, put it on Medium. make a screencast, go buy ScreenFlow or Camtasia and make like a little movie of you doing a thing that you figured out in the whatever the stuff is you work with that you're good at. Make it, doesn't have to have your face in it, can just have your voice and the screen. Make little movies with your computer, with your laptop, about how to do things. Put them on YouTube, tweet them, start doing those things, and build a portfolio of content that you've made that teaches your fellow developers how to do a thing. We were talking earlier on about helping new people feel comfortable. That's what you're doing. You're teaching and you're helping new people feel comfortable with a technology that might scare them.
And as a new person, you might be able to better speak to new people. That has been my experience. We have a comment from Steve. You just have to know more than the rest of the audience. You don't have to be an expert. And
right. And you're not going to know more than everybody, but you're going to know more than some people. And if you teach that in a careful and empathetic way, you're really helping those new people. It doesn't matter about what you don't know. It matters the kind of the gift you're giving to those newcomers.
Oh, I love thinking of it as a gift. So start becoming a teacher. Cora says, learn, teach, repeat. Cora's on my team. She's an advocate.
Hi, Cora.
We got Whitney and Tim from India. Hello. Thanks for coming today.
Yeah. Staying up late for us.
Yeah, I appreciate that. Steve says, start building a demo or teaching apps and put them into GitHub. And Nick says, being comfortable to explain something. That's a good way to get started. Excellent. Thanks, everyone. Okay, let's get into the meat of this.
Let's do it.
Let's teach and learn. Let's do this.
All right. Wow, event-driven architecture. So here's where I just start talking and you start drawing, right?
Yes. And I'll ask clarifying questions.
Okay.
Yeah.
Okay. Now, some context first. I think the best way to explain this is I want to talk about some microservices. And if you've seen me, I've given this talk at DevOps Poland before. In fact, watch my DevOps Poland talks. There's a kind of fictional for microservice e-commerce fake world that we'll get to. I want to put some microservices on the board.
Okay.
Talk about how they would be integrated without events, and then kind of refactor them to events. And
love it.
Once we do that, we're going to need to ask questions about how we understand what's going on in the system, which is we're going to pivot then into real-time analytics, which is it's kind of funny. My journey has taken me through event-driven architecture, and now I'm in this real-time analytics space because I see it as just a continuation of the same process that's unfolding. But
that makes sense. Yeah.
A little bit of framing before we get started. We are trained as software developers. So if you have a computer science degree, which is but one way to become a software developer, if you don't, and you have just spent some time as a web developer, as a person writing internal applications at an IT department, like whatever, you're writing software, generally business software. Sorry, I just saw a question. Komaraju asked about movie making. I can't go there right now. Maybe if we have time at the end. Such a good question that will literally take a half an hour. I love the question, but I have to push it away. So we're trained as I'll just say business software developers, right? Writing productivity software to think about a database, right? There's a database, and then there is an app that babysits the database. It's like we're all building CRUD apps with RBAC, with role-based access control. That's kind of like what we do. We just do it in a slightly different way over and over again.
Is it maybe time to start writing this down? Like we have an app and a database?
Yeah. And a database.
Yeah. So there's our app and our database here.
Yeah.
Okay.
And
all right.
The way I have always begun is by thinking about what's in that database first, right? And I mean, you got the basic idea of what the application does. There's some stories and all that. You're like, okay, I need to design this. What's the schema? In other words, I am asking, what is there? Okay. What's in here? What kinds of things are there in the world? Are there sensors and machines? Are there shipments and orders and trucks and trains? Are there credit card transactions and items? Like, I don't know. I'm just, it depends on what the domain is. I am thinking about what there is in the world. All right. What I'm going to be asking you to do in this first part of the discussion on event-driven architecture is to get away from thinking about what is and begin by thinking about what is happening. So fundamental. We're shifting from what is there to what is happening. Now, both of those questions, what is there and what's happening, we always have to address both. Okay, so in the former, we'll call it the data at rest world that we kind of come from, you still have to think about what happens because your application is going to have, people are going to be posting form submissions and, your web app is going to be answering HTTP requests. So there's still events, but you start mentally by thinking about what is. You don't start by thinking about what happens. And we're going to make that transition. So let's make that concrete by putting some microservices on the board. Could we, Whitney?
Yes.
All right. So there's going to be four microservices. And it could take, that's right. You can't draw over your face. Do you draw over your face when you lightboard? Do you draw over you?
But you don't. I right. Leave a very small frame for my face though. And I'll draw over the front of me. Yeah.
Okay. You're a professional.
Yeah.
I don't lightboard live. And, sometimes, we back up a little bit and there's some erasing and you never see that in the final cut because Tim drew over his face again. Anyway, all right. So let's start with, there is a service that receives orders. Okay, we'll call it the order service. All right, and there is some web or mobile app front end that'll throw little blobs of JSON at that order service. So wherever you want to go with this.
Yeah, I think maybe I need to understand all four, and then I'll figure out how they go together.
Okay. So there's an order service, and it's got a UI out to the world.
Okay.
And it validates the order, and then we're going to start by making it synchronous. Sure. So I'm going to give you lots of erasing to do. This is just nice. We have orders, then we have payments.
And like, should payments go down here? Like orders are going to talk to payment.
I'll go across.
Okay.
I go across. And then leave a little bit more room, and we'll have shipment. We'll have an order that has to make shipments happen.
Okay.
And then we're going to have a user account service called users service, right? So, I can create an account. I can edit my shipping address. I've moved recently. I've been editing shipping addresses all over the place. Now, two of these services have a front end, orders and users. So there's up there, some web UI. Their users has a UI, of course. Payments and shipments, maybe there's a way to look at history, but just forget about that for now. I need to place an order, minimum viable e-commerce site. I need to place an order. And what's going to happen when I do that? So we're over there in that UI, over on the left for orders, and I click submit order. I just ordered something this morning. I just ordered a little hobby FPGA board this morning. So I have done e-commerce even before I have streamed today. And that order service is going to validate the order, and then it wants to tell the user that everything's okay, right? But in the synchronous world, so this is not yet an event-driven world, the order service validates and then is going to make a synchronous call to payments. There's a REST call to it's REST, gRPC, whatever it is, doesn't matter. It's synchronous and it's going to call payments. Payments then is going to go out into the world. Maybe there's no user front end, but it's going to call a payment gateway, and that's a synchronous call, and it takes like half a second or a second, but it'll go out into the world and interact with the payment gateway. Payment gateway will say, yes, that card is valid. I had a card canceled due to fraud a couple weeks ago. This is another thing I've been doing, is updating subscriptions everywhere. And I went to the credit card statement. They're like $1,500 in fraudulent expenses that they didn't catch. So
wow.
Pro tip. Payment valid. It's good. His card works. It's great. Now we got to call the shipment service to tell the shipment service, here is the thing Tim bought. And by the way, Tim is user 24601 or something. Right? It's an ID. It's not, I don't know anything about Tim, but this SKU that he ordered and his money is good. Go ahead and ship it. Shipment service says, well, I'd love to do that, but the shipment service doesn't know anything about user 24601. I need a name and address. So now let me just call the user service and do that. The user service has some database attached to it. We should definitely attach a database to the user service.
Okay.
So there's another synchronous call there. This is our third synchronous call. And the users are there. And the user service queries that user database, says, oh, user 24601, that's Tim. He lives in Littleton. He's a great guy.
They have that in the database. Great guy.
It does. Yeah. And now shipments can go interact with the warehouse or whatever. Who cares? Whatever it does, right? Makes the shipment happen. And then it can say, hey, all these calls can kind of unwind, and the order service can say this is fine. The order has shipped if you do this entirely synchronously.
So yeah, so then after the database is gone, then we have to go all the way back like this to tell the user, is what you're saying.
And that's a little bit of a straw man. Okay, even in the synchronous world, it does not have to be hyper synchronous like that. And a lot of people will, even if the services are calling each other synchronously, the order service might not wait for all that. I don't mean to overstate the case.
Yes,
because that would be pretty fragile. But when we are synchronously integrating like this, which it works, okay, everybody watching the stream, watching the video later, of course you can build systems this way. People have been doing it for years. It is successful. It's just tricky, right? A lot of the kind of contemporary distributed systems development patterns are, like, I'll just say circuit breaker, are all designed to mitigate problems that arise from synchronous integration. Naming and service discovery is harder with synchronous integration. So it's fine. It works. It's just maybe not the best life choice. And you're missing some things, right? Like all of these synchronous calls, they're ephemeral. Once they're gone, they're gone. Like what payments happened, what shipments happened. I guess I could log stuff, right? I could put them in a database if I wanted to, but there's nothing inherent about my integration mechanism that's helping me keep a history of what's happened. And that history of what's happened might be interesting. I might want a log of orders that have been placed, a log of payments that have been cleared, a log of shipments that have happened. All of that is very interesting. So I feel like I should pause talking a lot here. This is always fun.
We do have some.
Take a breath.
Yeah, we do have some questions. We have a hello from Pakistan. That's super cool. Hi,
hey,
thanks
Zain.
for coming.
Hi, man. Thanks for staying up.
Yeah. Han asked what's happening here, but Nick came in and let him know we're talking about microservices, event-driven architecture, and more.
Thank you, Nick. I'm glad you answered that because I was not sure.
And I'm waiting for the board to be filled and her crouched in the bottom right corner, face only. It's only a matter of time. When I was doing the cartographer one a couple weeks ago, I made a space for myself that was a little lower than my normal stance. So I was just standing with my legs. But the problem is I have sock feet back here, so I kept sliding anyway. There's like so much drama happening. And then what is a sync call here? Here's a real. Is it code or any other service?
It's either HTTP or gRPC in practice, right? It's the idea is, okay, think about think about this not being microservices, but a good old monolith, the way things used to be, or just in code, you have some function in an object over here in some other module, and you call the method, method or function or whatever. That's a synchronous operation because execution goes into the method, executes in the method, and returns. And the calling code doesn't do anything until that's done. And unless you return a future and make life hard or something, just put that to the side for a second. A method call is a synchronous operation because the next thing doesn't happen until the method call is done. Now, in the first step, it was actually the second step in the microservices world, was to keep that synchronous paradigm. So in the code for the order service, there is a method call that says, here's stuff about the order, please get this paid for. It's just what happens in there is now a network call. So a socket is opened, a payload is sent across that socket to the other service, and that payload is received, and the work is done, and a reply is sent. So synchronous, in detail, it means a network call, but in principle, it means data is transferred, work is done in the other service, and then a reply is sent back, and the calling service waits for the reply. That's what synchronous means.
Yes, that's great.
And Connie says sync calls are not recommended because they're blocking. That they're blocking is one thing that is difficult about them, and that leads to various approaches to managing concurrency that can be hard to work with. And so, yeah, that's one reason. What I'm getting at is not so much that they're blocking in the calling service, because maybe that's fine, right? Maybe you've got threading happening over here and it can block and another thread can run and you don't care. What I'm getting at is this is a distributed system, and having the elements of this system communicate synchronously makes for a more fragile and more complex, more difficult to manage system. There is a broad consensus on that point. And so we would rather not do this. What we did when we took perfectly sensible programs and broke them into services is we came up with a mean name for them. We started calling them monoliths, and we decided that that's bad. A monolith is bad. And so you can't have just one program. It's bad. And now you want lots of programs that talk to each other. And it turns out there are so many good reasons for that, right? It's a great idea, but we all unknowingly stumbled into the world of being distributed systems developers, and that's a bad life choice. Okay, Fule says he likes my you like your monoliths. I'm glad you do. They have a place in the world. Now, there's I'm not really here to debate microservices. I'm just going to say let's assume the reasons for adopting them are good. I'm just trying to point out there are significant trade-offs, right? It's a lot harder. To build a.
So you're saying there are reasons to stay with your monolith, just because, And I agree with you that the term monolith is definitely has negative connotations.
Oh,
but
sure. I mean, I am thinking of Australopithecines beating each other with femur bones. Am I the only one? Somebody help me out in chat. Somebody got that.
Copper Beardy, hello, welcome. And then we have, can we log using time series database of events?
100%.
Question.
100%. You absolutely can. So you can do this. And I'm saying, but you need understanding. You need a record. Yes, you can. In fact, I'm going to tell you, you will. So you will stand up some piece of infrastructure to log those things eventually. Whether it's a relational database and you use it like a log, and that's great. Or you have a dedicated time series database or some other kind of logging thing. Heck, use Kafka. Well, Kafka's going to enter the chat in a minute here. So you're going to log stuff. Thank you, Rick. 2001 Space Odyssey. Oh yeah, that's right. I talked about that in that talk too. I remember all my talk, Rick. Am I right though? Anybody who's seen that movie, come on, there were definitely.
So Nick has a clarifying question. I don't know if this is correct, but sync calls, it does not necessarily mean blocking code. We could use sync calls by using the async await, thus releasing the threads appropriately.
I tried to say that, like I'm creating this very rigid straw man, synchronous is bad kind of thing here. Like, well, you can't reply to the HTTP request in the order service until the shipment is, no, okay, yeah, you're gonna do better than that. And I'd said when talking about method calls that you can return a future and have asynchronous behavior and effectively not blocking method call. So there are more sophisticated accounts there, but they don't undo the fundamental fact that the communication between services is synchronous. I can send a request and have an asynchronous non-threaded programming model inside my service. I still have to wait for the response to the request. I still am in the frame of waiting for a response to my request, whether that is in waiting on a future at some point or not.
Mm-hmm.
It's hello, respond, request, respond. That pattern of interaction between the services is fixed. Maybe you can argue with me and show me something I'm not seeing, but I do want to be clear, Nick, you're totally right. And I was trying to throw asynchronous models a little bit of a bone in terms of the code in the service. It's a thing, but this is still synchronous integration, even if I'm using futures internally.
I have a question then. Can we say synchronous is like a one-to-one interaction between two different microservices? Would that be accurate?
It's an interaction in which, maybe, and Nick, maybe this will help. Maybe if I don't say synchronous, maybe if I say request response. It's a little bit imprecise of me to use those as synonyms. I usually do use them as synonyms, and I admit that that's a little bit imprecise, and you're pointing that out, Nick. But if we can say request response and be okay with that, that is the pattern that I'm describing here, and that's what this is.
Excellent. Salaboy says hello. Hi, Salaboy. And then Nick has a response for you. Yeah, that's what I'm trying to clarify. Sync means we just have to wait for response, not actually blocking code or something, because I see a lot of developers confusing the two terms.
Yeah. I think we're on the same page.
Cool.
I think we're on the same page. I'll be here all week. All right. Now, let's change this to be event-driven. So we're going to refactor this system to be event-driven. And when we're done with that, we're still going to have some analytics problems that we're going to need to solve. So that's the next two layers here.
Spoiler alert. Got it.
Do you exactly now, Whitney? So question, surface area strategy for you. Do you want to erase things here and change them, or do you want to draw a new system to your left?
How would you draw a new one here? Over here.
Over there, or
sure.
change. Well, we'll figure it out. Okay, let's draw.
Yeah.
Okay.
Let's draw a new one.
Okay.
And then we can always erase one if we need to.
Exactly.
Cool.
Same four services.
All right. Should they be linear like here?
Yeah, if possible, a little more space between them, because the way they talk is going to be a little different.
Okay. So I'm going to do.
There we are.
I'm going to make it a different color.
I like it.
It's my artistic vision, Tim.
Yes. You own the artistic vision here.
I have backups nearby for let's do users. I have to look at my screen to make sure.
That. Manoj says he saw my talk at DevOps and started studying designing event-driven systems by Ben Stopford. That is an excellent book on this topic.
What's that?
On just this event-driven side of things. Really good, short, focused introduction.
Okay, there's very slightly more room in between.
Excellent. And we'll use that space below them. I should have said that. Oh, by the way, we're going to use the space below them. All right. Now, Same thing. You got, and you don't have to draw the UI because we understand there's a UI for orders and users.
Okay.
And by the way, the UI for users, I think I said this before, that's like just CRUD on your account, right? I can create an account. I can delete my account. I can update it. I can view it. That's CRUD on the entity that is me.
Got it. On the nice guy, the great guy.
The great guy. He's a great guy.
The great guy feels if that ever needs to be altered, you would do it through that UI.
Exactly. Hopefully there's no status change there. Now, instead of some kind of synchronous interface like HTTP or gRPC, and again, those are synchronous. However, we want to define that in terms of the programming model. That's a good question. How do you debug an event-driven system? Well, we haven't built our event-driven system yet, so let's get there. We're gonna get there. That's a great question. There are some folks asking if we helped develop VMware. No, neither one of us did that. Neither one of us did that. Right. Okay. When an order comes in, instead of calling the payment service, what we're going to do is we're going to have a Kafka topic, and orders is just going to produce a message to that topic. So that's just a log that sits in between orders and payments. There you go. Draw the little zip, zip, zip. Yep, perfect. Talking to the other Kafka light builder here. Okay. Yeah. So its orders is just going to produce, and if you could put them like a little bit below and in between, if that works too, you produce a message to that topic. And here's a key insight. All it means is I have a valid order.
Okay.
That's it. Do I expect anything to get as the orders service? Do I expect anything to happen with that? No.
You don't. You're just putting it out there.
You're just putting it out there. You're putting it out there. You're treating your other services like an adult. You're not going to overfunction and stand over the shoulder of the payment service and make sure it does what it's supposed to do. That's terrible. I mean, you wouldn't treat your friends that way.
I trust you. Yeah, I love it.
I trust you. Yeah. And by the way, this I belabor the point because this is a big psychological barrier to get over because we're used to making sure the thing comes back. Even if we're, like I said, even if you're waiting on a future, you're going to wait on the future at some point. You're going to check.
As a parent too, it's a hard mental hurdle to be like, here's the information. I trust you to do what's best. Well, I don't need to look over your shoulder.
As a parent, there are like developmental aspects to that. If it's a 3-year-old, there's not a lot of trust. You're gonna make sure the thing gets done. Actually, my oldest has a birthday tomorrow. He turns 28. Like, nice. No, it's not how it works with an adult. You just number one, you don't really tell your adult children to do things, but you might give them information and you let them make decisions. It's just like event-driven architecture. So we produce that message to the topic, and that's it. You're done. You've produced the message. So this is atomic operation. It succeeds. Order service done with its work. Move on. Wait for the next order. Now, of course, we need that order to get processed. The business needs things. So payments is going to consume from that topic. No, Solid Boy, you should treat your microservices like adults. You shouldn't treat them like babies. Don't treat them like babies. That's the whole problem. Then you're going to find yourself building request and response topics in Kafka.
Okay, so we produce this particular Kafka topic, we're producing with our orders microservice, and we're consuming with our payments microservice.
And payments is still going to do its work. It's going to talk to the payments gateway, do its work, and then it's going to say, "Oh, well, okay, I've got the money." Or maybe I don't have the money, but we're just happy path. We're just lightboarding here. I'm trying to make the concepts easy. I just said no. The question is, what if an order fails to process? I just said we're doing the happy path here. So maybe come back to some of that. What's that?
I'm just repeating what you said.
Oh, okay. Okay. There are so many good questions here. No, we're not going to put it in a dead letter queue. In the case when we have the money, we have to enrich the order with some number we get back, some code we get back, and now we produce a new message to a topic of paid orders or something like that.
So I'm putting it in a different color to denote it's a new Kafka topic.
And Whitney, as you're drawing, oh, go ahead.
Oh, nothing.
Okay, I want to real quick talk about failure here. It's if a payment didn't get settled, then there would be another topic. It's not a letter queue. It's a different topic of failed payments. And so there'll be a service. Think about how this works in actual e-commerce. What do you expect to happen? You click order and you get a page back that says, thank you for your order.
Mm-hmm.
Did anything happen? Nah. But the HTML that the order service renders, or it's going to send little bits of JSON, and React is going to do stuff, whatever. That page that renders in front of me says, thank you for your order. And that's it. Now, because that order service has run to completion and the work is done. If payment fails, let's say I'll get an email saying your payment failed. Click here to try again. So payments will produce a failure message to a different topic, and there's a service that will consume from that topic that will generate an email. You don't have to draw that, Whitney. I just wanted to. There were a bunch of questions about that.
Yeah.
Your call. I'm kind of going off message for a minute because Fule had a few questions about that, and it absolutely fine. Of course, orders fail, and what you're acknowledging here is that the entire world is asynchronous.
We have the chat's been going nuts, which is great. This is I always have a wonderful chat, but this is especially a lot. So I'm gonna try to say hi to everyone. Hi, it's Litany. Nando, I haven't seen you before. Welcome. Kafka's PTSD. Fuel Snable, you have PTSD about a lot of things. I don't mind being a Kafka dev, but I had to maintain a misbehaving Kafka cluster. Findle's here. Hi, Findle. Zookeeper especially inspires dread. Findle says, I never ever trust my payment systems. I think that's an interesting point. That are we going to trust? We maybe haven't gotten into our sensitive user data, but how do we feel about trusting that in an event-driven architecture model?
We want to keep it in the sole custody of the user service is the answer. There's sensitive things in there and they need to stay there. And to get them into, well, we're going to talk about how to get them into shipments because that's a thing we're going to need to do.
And so we have, what if an order fails? We talked about the dead letter queue from Snable, my life. How would the payment system send back a UI update? So that's what you already kind of mentioned about maybe going through email.
I waved my hands and said, it's going to be an email, right? If you want it to be a UI update, then what you're going to need is, and this be a React kind of thing. Some part of the page is going to have to update saying, oh, wait, this thing happened. That implies that there needs to be a way down here in the event-driven world where I can look at current state. All right. And I'm going to ask you to wait for me on that because we're going to introduce that mechanism when we get over to users.
Excellent.
What is the current transactional state? And once this is all built, we need to understand still materialized state, but from an OLAP perspective, not an OLTP perspective.
I assume we're going to get back to what OLAP is, or is that like an acronym that is? Oh, yes, I don't know that acronym.
That's me being rude, tenured tech person and using acronyms without introducing them. That's actually terrible. We will get there. That's the whole second half.
Okay. And then we're talking about a saga pattern. Is that maybe a level of complexity we're not going to get to today in terms of event-driven architectures?
No, we could briefly say this is a saga that I'm telling right now. I want to buying a thing is a saga, and there are little bits of the story that individual services fulfill, but the set of the interactions of these services that accomplishes some high-level business objective, that's a saga.
Okay. And I guess this is similar, like a pattern that's less linear. So like orders produces to this Kafka topic, but it doesn't have to be payments that consumes from it. It could be any other microservice consumes from any other topic.
Boom. Because the MVP that we're putting on the map here you place orders, you put them in that topic because payments needs work to do. That's all you're thinking, right? Well, what might happen in the future with that data? Here's what's so cool about this. We've got this log of transactional data. What if you needed some other real-time process to run on that, like awards for your most valuable customers? We want to send you a coupon or something like that. You can consume from that topic. That really, well, no, that's really more of an analytics thing. We need Pinot in the game for that. So let's hold off on that. Fraud detection would be another thing. There might be a fraud detection service that we want to run on that. We didn't write that right away, but we'll write it later on, and it'll consume from that same topic. Anything that you want to be reacting in real time to the events, to order events, is now a service that can consume from that topic in addition to payments. So that's what's cool. When you're synchronously calling another service, you're saying, well, my work here is to tell payments to do this. And then it's done. When you're using effectively distributed event logs to communicate events, orders is saying, I have an order.
I don't care who consumes it. I'm not telling anyone in particular. Yeah.
I am not. You're adults. And so new things can emerge. So you get this like evolutionary dynamic in your services where new developers, new business units, new product stakeholders, whoever they are, can say, hey, I want to do this thing. Oh, look, here's this data. I can do it.
I love that. We have a question from Mazen. What is the difference between event-driven microservices and a typical streaming pipeline like Kafka Streams pipeline?
Okay, so Mazen, I'm going to give an answer to that. Other people might have different answers, but when you say streaming pipeline, what that makes me think you mean is streaming ETL. So I've got some kind of real-time analytics that I'm computing on an event per event basis. And you give the example of Kafka Streams. If you're using Java, that's a great API for doing that. So if you're going to handcraft some kind of analytics, real-time analytics calculation in a Kafka Streams application, that's like super expensive, super high touch, but very powerful, right? And then so you're consuming from these input topics, doing some kind of analytical roll-up, computation, join, enrichment, blah, blah, blah thing, like one does in analytics, and producing that result back to a Kafka topic for other services to consume and act on. That's a streaming pipeline.
Okay.
Now,
so in that case, this is
build your whole analytics stack that way. That would be extremely painful and expensive, but that's a streaming pipeline. This is event-driven architecture using Kafka topics to move events back and forth between services.
Excellent. Steve answered. I was going to ask you what the ETL stands for, extract, transform, load.
Thank you, Stephen. I'm just, yeah, extract, transform, load. We can talk about that. Yeah.
And so what I heard about so what you're saying is it's possible to have one pipeline, like we're talking about different topics, but have one mega topic where different services consume and produce that same topic and enrich the events as they go.
No, I didn't. Okay. I didn't mean a mega topic. I would like topics to be special purpose,
Okay, that's the
domain
best.
Specific.
Okay.
Yeah, you could do the other thing, and there are reasons to do the other thing, but let's not go there. That would be
okay.
That would be
sounds good. We haven't got it yet. We're trying to make our way to real-time analytics.
Yes, and we have till noon Central Time. It's funny. Before we started rolling, I'm like, I think this will only take 60 minutes. Whitney's like, yeah, that's cute. That's adorable, Tim, but no, that's not going to happen.
We have too much fun here for it to be a short
here we
stream.
are. Yeah.
Is it possible to make your volume louder? It seems to be. I guess you're at 80 and I'm at 100, so it's not that disparate. But just a request. I honestly don't know how to turn mine down.
No, mine is now clipping a little bit, so
okay.
I'm going to try just to have this closer to my mouth.
Oh, there you go. That's a great
better?
way to do it.
Okay.
Yeah.
It's still a little hot.
Okay, and
not like to clip.
And one more question, I think. Once the payment is done, can we send a request to notify that the payment is done using Kafka?
You can. You shouldn't. So, Manoj, this is an opinionated statement. But remember, when an order is validated, you put that message in the topic saying, here's an order. The order service doesn't wait for it to get done. So that's too much state. It's too much for it to remember. It doesn't scale. You need that work to be simple. So produce the order. It's atomic. It's done. Here's the order. Everybody else pick it up. Make sure it works. Now, ops is, and people with a more sort of DevOps kind of orientation are going to say, wait, what if something goes down? Obviously, monitoring, observability, still a thing, right? We need to make sure the system is working. It's just that the order service doesn't take on that functioning. It doesn't say it's my job to make sure the system's up. It's somebody else's job to make sure the system is up. The order service, hard enough to write by itself. Just think about orders. That's all it's going to do.
Excellent. Fuel Stable says they had a Kafka cluster with 1,000 topics. Yeah, it had biggest 200 partitions and 3 replicas. Yeah, PTSD. That's probably the source of your PTSD, huh? Okay. Oh, I think maybe at some point we'll need to move on, and then we'll catch up on chat again but we have from Steve, sometimes blocking can be the right call even in this architecture. For example, if I need to make sure the message is received by the messaging server.
Yes, Steve, and I'm just going to say less often than you think, right? Part of the goal here is to get away from, I need to make sure you got that, and get to, I've done work, I've received an event as an input, I've done work on that event, and I've produced an output, and have services orchestrate, choreograph their work to get larger chunks of work done. That's the goal we're going for. So yes, there are synchronous things, but generally services talking to other services, we want that to be async, and we want the synchronous things to be on the edges of the system when we're interacting with the world. Now, paid orders, shipments picks up paid orders, right? And once again, it says I have an order. User 24601 ordered a web FPGA prototype board. Oh wait, don't draw that yet.
Okay. Oh God, I got excited.
That's right. Right. That's right. This is where it gets tricky. Remember, users has a database. Okay.
Mm-hmm.
Users has control of a database. That's got users in it. And what we don't want is to synchronously ask users. We could, right? We could just go say, do a call, do a database lookup, and give me the thing back. Fine, But if we're trying to live this asynchronous life, that what I'm trying to think of how to make this. Okay. That database is owned by that service, and we don't want to take a copy of that mutable data and give it to the shipment service. That's bad, right? We want that one service to completely own its context, and that includes user data. There are even potentially regulatory reasons for that, but there are also just design reasons for that. We want that service to own that data, period. So creating an account modifies that database. Updating an account modifies that database. What we can do now is create a change log of the changes in that database. So here's our Kafka topic. And I'm gonna wave my hands a little bit. If you have questions, ask them, folks, and I can dive into it. But when a change happens in that database, we're going to produce a message to a Kafka topic. And that message is something like, Tim just opened an account. Tim just changed his account. Here's a new copy of his account, his address. And so we're able to select just the things that shipments needs: name, address, phone number. That's it, right? Name, address. There could be other things in users, but we're going to create a Kafka topic from the database. Anytime there's a change in the database, we're making a change log. So now here's our Kafka topic. That's a perfect location for it. I love it. And that is coming from the database. And so this isn't an event stream. like the other two, paid orders and placed orders, those are proper event streams, just things that have happened. This is a change log of changes to an entity. Yes, Nick, lots of bots. I don't stream a lot, so I'm not used to this bot life. But
if anyone from my team is here and can log into StreamYard and help get rid of the bots, that would be great.
I actually am interested in buying some followers, and I've been looking around. This is very, very helpful and relevant. I definitely want to become famous. So,
thank you, bots. I've been waiting.
Been staying up late at night. Like, how can I be famous? And now it turns out there are these helpful services that are just for a few Bitcoins are going to help me do it. All right, so we create.
Thank you, it's Litany. Yeah.
We create this change log, and what now we can do, and this is kind of still all inside the Kafka ecosystem. The shipment service can consume that change log and make like a little local copy of the data, of just the subset of the data that we need. Again, filtering out the other potentially more privacy sensitive stuff, just name, address, and phone number. And so shipments is creating a local copy of that database. You can do this with Kafka Streams most immediately. You can do it with Kafka Connect and a local Postgres instance. It's all part of the game. And there's our database. That is effectively a read-only copy of the change log. And that change log in yellow that Whitney drew down there that we extracted from the user's database is also an immutable event log. Okay, it's a Kafka topic, so it's got to be immutable. Those events in there, once they're produced, they don't change. So the sensitivity to copying data and having it in two places is that it might change in two places, and that's bad. Now we know we have a read-only copy. So there are still eventual consistency concerns, right? It's going to take a fraction of a second for me to have an updated copy of the user after the user service has it. But in this case, that's not a problem.
And then this is what I'm wondering. So if we're capturing all the database changes, aren't we eventually, if someone updates their credit card or something, going to capture something that's too sensitive for shipments to have access to?
No, because we are in control of what changes we're materializing. So that change log isn't going to be everything from the database. We're not going to have credit card numbers. Never, never, never. Right. Those are encrypted in the user database. Ooh, don't touch them. We are taking a filtered version of that and just projecting the fields that we need into that database. So that topic, again, regulators care about what's in that topic and what's in that database. We don't want things to be in there that regulators care as much about.
That's great.
And I mean, it's SOC 2 auditors. They're sort of regulators. They aspire one day to be regulators.
We have some just love how we've secured our core database. Yeah.
I will take that as not at face value that we have helped secure our core database, and the stuff we're getting putting in other places is safer. So we have this now completely asynchronous thing where all these services are interacting asynchronously.
Nice.
And that's and so orders, like if I wanted to stay on that page and know what the current status might, like ordering pizza, the Domino's app these days, it's now being prepared by Cindy, and someone's walking it to the car.
The cow is currently being milked to make cheese for your next pizza.
Right.
Yes.
All right. So this is all the transactional universe here. I said OLAP before, so excuse me. This is all. This is not OLAP yet. This is transaction processing. The kinds of databases, we're kind of departing from the database world a little bit, but the databases that we're talking about, like the user database, is a transactional database or an OLTP database, online transaction processing. So that's a perfect space to write that OLTP. Thindall, LDAP. No, that's not as exciting as OLAP. No, it's not. Yeah.
Excellent.
Binding to entities and stuff.
What is this?
So, and this all works, right? It works great, but when you want to start understanding what's happening, we've kind of broken that. It's all you've got is logs of things, and it's like if well, Whitney, you were talking about card catalogs before, and our younger viewers may not know what those are, but there was an indexing system, a topical indexing system, where you had a numeric code that you had this little reference chart, and you could say, well, stuff in this basic range would be here, or you'd have something
the Dewey Decimal System.
The Dewey Decimal System.
Yes.
By an index by title or an index by author. You'd have a few indexes, not many. Which is frankly, if you know Kafka, that's kind of like Kafka Streams, a Kafka Streams K table. You get one index. That's it. As many indexes as you want, as long as it's one, and that's not a lot of fun. But reading a log is like a card catalog that's maybe sorted by ID number or something, and you just have to page through and look for the thing you want. You can't get insights that way. All right. They're great for services to communicate to each other, but you have no way of understanding what's currently true about things in aggregate. Right.
That makes sense.
That is an OLAP question, or an online analytical processing question. OLAP, OLAP. So I'd said OLAP, and you pointed out that I didn't define it. So OLAP is online analytical processing.
Okay.
And
so OLTP is what's currently being done, and OLAP is what we want.
Yes. So the essence of transaction processing is you are reacting to a thing that happened or engaging in an exchange of value. It's easy to think about e-commerce transactions because they are exchanges of value. I am sending Federal Reserve notes to you. You are sending me an FPGA prototype board so I can do some hardware hacking. And that is a transaction, an exchange of value. And so all of these services are interacting around that transaction in the business, that exchange of things. OLAP is not about processing a transaction. It's about trying to understand what is going on with the transactions.
I like that. So understanding. I need a light board that has spell check.
Don't we all? I did a take a couple weeks ago that I wrote Apache. I had 2 A's in Apache. And the first A looked like an H with a ball cap on. It just, happened.
So
historically, OLAP has been about telling us what has happened.
Oh, okay.
Right? So in the old days, when hard drives looked like that, I should get, by the time we're done, I want to get the ST225 and actually hold it up. Anyway,
yeah.
When OLAP was young and ETL was young and all that kind of stuff was really being worked out by innovators and people developing important new technology, the best we could do was to take all this stuff that's happening. Like we didn't have Kafka back then, but if you did, or you wanted to do it in the old school way, you would extract those events at night from the Kafka topics and put them in a special database that you could then run analytical queries on tomorrow.
Okay.
And that in the 90s, that was space age, right? Wow. I get a complete understanding of what has happened in the business up till tomorrow. Mind-blowing. It really was. And fortunes were built, consultancies were grown. And it was a really, really meaningful innovation. But fast forward to now, and yesterday is a very long time ago, right? That's not how things work.
I wasn't hungry for my pizza yesterday. Like, yeah, who cares about that? those
seriously,
analytics. Yeah.
Seriously, Whitney, you weren't trying to order a burger yesterday. And you know, 50 people like you in your chunk of your zip code weren't trying to order a burger yesterday. You're doing it right now, and you need to understand that right now. So this kind of event-driven system that we've built really points out the tension between the way we used to do analytics and the way we need to do it going forward. Because this whole system is designed around what is going on right now. And someone had asked about streaming pipelines and Kafka streams before. And so I can absolutely do that if I've got some kind of very specialized case where I want to sit down and write some Java code to kind of take the Kafka streams primitives, and I've got this topic and this topic. I'm going to join them, and I'm going to write an aggregation function to do this thing. And that's pretty high touch and pretty expensive compared to, say, writing some SQL code, you know, SQL query and having that execute. But there are those tools in the Kafka ecosystem for doing that. It's just they're pretty specialized, and it's not this comprehensive real-time OLAP solution. So something is missing here. Let me, as we pivot to talking about real-time analytics, let me put that a different way. There's this tech stack that's changing. Okay, it used to be, here's a database, and here's a web framework, and here's the front end, right? That's how I grew up as a web developer. It was great. I started using JSP at JSP 0.92 before it was in 1.0, right? I was brand new to the whole Java world. This is at the end of the .com boom, so my timing was impeccable. And you know, we use database, web framework, web front end. Love it. That's the old stack. Now we've got this new stack where here's Kafka. Here's this like logging substrate. ASP Classic and Perl. It's Litany. I want to shake your hand. What's a class? Actually, never wrote any Perl, and I'm okay with that.
Okay, that's what it used to be. And now we have Kafka at the bottom?
So now at the bottom, there's Kafka. Okay. And we still have our front end at the very top.
I'm making up how Kafka should look.
Yes,
now we have a front end.
Up super high there. I want to get some. There's more.
Oh, there's going to be a lot.
There's some uncertainty in the middle.
Oh, okay. Need to...
And you know, web framework, it's a slightly different picture. Let me just say, underneath the front end, however you want to write this, is our differentiated application code. In fact, you know what? Whitney, let's just compress all that. That's our application code is up there.
Okay.
And that's the actual stuff that we build that services our customers. That is different than how our competitors do things. This is how we as a business distinguish ourselves. It's that code that we as software developers should be focusing on. What is the differentiated application code that actually makes our business unique and cares for our customers or users in a unique way? So key. All right. That's where we should live. Now, and we kind of understood how to do that in the old world, database web framework front end. That world is gone, right? We're mostly having to transition to this new microservices world. What has happened is everything in between application code and Kafka right now is in this weird up for grabs state. And that looks like a COVID virus. Now, it's in this weird up for grab state. And so what we're having to do is, in our differentiated application code, we're going down that stack too far. We're having to write a bunch of stuff that we shouldn't be. Yeah. So our application kind of filters down that stack in a fuzzy way, where we're duplicating things that should be done by infrastructure. For example, I need to calculate who my most valuable customers are. And I need to know right now, is anybody making a big purchase, and they just put a bunch of things in their cart, and I should text them coupons so they'll finish the order or something like that. And it's time sensitive. I need to know now, especially if it's food, right? Because they're going to eat. You need to know. Now, I could go write that with Kafka Streams, but I'm kind of believe me, I'm not dumping on Kafka Streams at all. It's an amazing API that is absolutely the right thing to do for some things. But in a lot of cases, when we don't know what that infrastructure should be, we should be focusing on this little slice of application code, but we're having to go down the stack in an interesting way and duplicate what should be done by infrastructure.
Okay.
And unless you're an infrastructure developer, and you know if you are, you shouldn't be writing infrastructure code.
App logic doesn't belong here.
No. And it's kind of never app logic. It's an application that just became distended and grew down into an infrastructure layer. And it's happening because we're in a new space, right? It's not happening because developers are bad at their jobs. It's because we don't know how to do this, and the right infrastructure isn't always obvious. How do you do that? What is the right way to do that query to determine who I should text a coupon code to within the next 5 seconds? Like I need to know right now.
So what does belong in the infrastructure layer?
Okay, that's what. And actually, not Star Tree. Not Star Tree. Apache Pinot is the thing that is one of the missing pieces here. Okay.
So what are some other missing pieces?
I guess we sort of don't know yet, is my point, right? We don't know in that fuzzy range. We haven't figured out what all the missing infrastructure is. And so everybody who's doing event-driven architecture is writing all this stuff they shouldn't be writing. I mean, it's best we can do. It's all we know right now. So I don't know, other than real-time analytics, I don't know what other classes of infrastructure are going to emerge there. But I'm saying we certainly know that understanding what's happening overall right now is a thing that we need. So where Pinot enters the page, that's Kafka's sister Apache project, it's now a giant analytics database. So we have one big analytics database this is kind of a one database. You said one mega topic. This is like one mega analytics database that we can stand up alongside our Kafka cluster. And this is the cool thing, that it is a piece of infrastructure, and you can deploy that infrastructure and not have to think about how to rewrite each analytics calculation one at a time.
So Apache Pinot. I'd love to know where that name Pinot is a grape. Grapes are clusters. Anyway, where that name came from.
Actually, I think the creators liked wine.
Just that simple. Sometimes things aren't hard.
I affirm them.
I want to take a moment before we jump into Pinot to catch up on the chat. And see if we have any questions about what we've already gone over. And I do see one from Marco. How would that projection work from users to the changelog? Practically, would it be like a cron process that periodically queries the DB? How does it recognize what's changed in the database?
Excellent question, Marco. There are two ways of doing that. One is query-based. It's called change data capture, CDC. There's query-based CDC and log-based CDC. Query-based CDC you do if you can't do anything else. It's not good, but it works. So like you query every second and you'll get new or updated. You can potentially get inserts and updates that way. Log-based CDC is a connector that listens to the change log of the database in an implementation specific way. There's a really cool open source project called Debug that does this. Broadly, this is the task of Kafka in the Kafka ecosystem of Kafka Connect and Kafka Connect connectors. Debug is more than a Kafka Connect connector, but it is also a Kafka Connect connector. So yes.
I've heard of change data capture and Debug in the context of migrating a monolith to microservices as a way to migrate data.
Absolutely. Totally a tool for doing that too. But it's also one of the ways that you could get this done. There are other ways, and it's out of scope to deep dive, but that is totally the answer to that question. Debug and have it listen to the log, and anytime there's a change in the database, it produces a message to Kafka. Thindall, very funny. CDC, yes.
Thindall. Oh, yeah, we have
write-only language, Perl.
This is, so I'm way behind on the chat. I'm sorry, y'all. But Dogme started, oh, sorry. It's quite cool sitting on my DP 900 tonight and just finished rereading some sections, which was covering OLAP. Oh, so it's just like serendipity that you were just reading. Yeah. I don't know what a DP 900 is that you're just reading and then it comes up today. I love that. Man, there's so many acronyms today that I just am not privy to. So note to self, write OCR software for light boards. I suppose that is going to be my spell checker somehow. Oh yeah, OCR spell check and a robot with a red pin. And then, so OLTPs are for writes, according to, and then OLAPs are for large expense reads.
Yes, I think I know who this is. Hello, Zitcher. And yeah, that's one way of putting it. There's a lot of ways of describing the difference between OLAP and OLTP.
And then what's actually like, this is like software for processing?
They're just two different types of database, really.
So these are databases. Okay.
Yeah. And it's kind of like in this event-driven architecture, we sort of created our own special purpose distributed database. The orders, payments, shipments, users, all these logs between them. It's in a manner of speaking, we built a big special purpose database that does a thing. And it's like this big OLTP database. And now we need an OLAP database to understand what's going on there.
And so is Pinot a type of OLAP database?
Yes, it is.
Okay.
It is.
And so there can be other types of OLAP databases.
There are so many of them. In fact,
okay.
I mean, probably no, I think by the numbers, the most common OLAP database by revenue, I think, is Microsoft SQL Server.
Okay.
And in the open source world, it's probably going to be Postgres. Like people build OLAP systems on top of general purpose relational databases that can also be used for transaction processing. So it's possible to.
Okay, so those though are what was used for what has happened, and what Pinot is bringing to the table is having real time access to the data that is freshly written to your database.
Yes, because those rely on a batch process that runs occasionally. You know, used to be at night. Maybe it's every 10 minutes now, if you're lucky, every hour or whatever. But it's a batch process that extracts new things from the transactional world, transforms them, and loads them into the OLAP database. That's the ETL, extract, transform, load. That's a batch process. So if you need to know what's happening right now, then ETL is not your friend. You can't do that. And again, I always need to be careful. There's lots of ETL jobs running in the world right now. Lots of data warehouses built in SQL Server. I mean, that's kind of in the data world. That's like talking about your monolith. You know, you have to be a little countercultural to want to defend that. It's supposed to be the old and busted, embarrassing, stupid thing that you're trying to get rid of. You know, but oh my goodness, let's not overstate the case. It's great technology. It delivers value. There are still these things running that are good. It's just that paradigm isn't going to get you to where you need to go. It's like trying to scale a monolith. It's like doing all this integration between your services synchronously. It is going to break. We do need to move, in the case of event-driven architecture, to asynchronous patterns of interaction between services. And in OLAP, we need to move from batch processing to real-time ingestion. And that's kind of the Pinot insight now is, let's not do an ETL process. It was a good idea, but it's not going to work, because I need to know maybe in less than a second what just happened.
Mm-hmm.
So
I'm hungry right now. I won't be interested in 15 minutes at all.
And I want to know, and this is actually a real use case with Uber Eats. And by the way, I mean, Pinot is just one real-time analytics database. There are a few. It's the one I work with. It's the one I'm talking about right now. But this is a new thing that people are doing. Kafka has been around for a while, and this kind of event-driven microservices thing is getting some legs under it, becoming pretty well understood. But doing actual real-time OLAP is a relatively new idea that is getting traction. And so what we do, instead of extract, transform, and load, is we constantly ingest from those Kafka topics. Orders are being placed, payments are being cleared, shipments, whatever, suck it all into the database all the time in real time.
So in your system, every topic that's being produced, it's being consumed by other services, but it's also being consumed by the analytics database.
Yes.
Yes.
So you could, I think, if I'm just imagining the layout of this light board, up above users and by what is happening and all that whole big space up there, just one big giant database. That up there, yeah. And it is constantly consuming from Kafka topics, can be consuming from databases. It doesn't have to be just Kafka topics. We can still do CDC. But any transaction that happens, as quickly as possible, you want to get that into the database. If it's Kafka, it just so happens, that's why we spent all this time on this kind of Kafka-centric world. Well, I mean, it's interesting, but it so happens that it's super quick to get that into Pinot. It has this like native Kafka ingest support.
So what we want is a real-time analytics database.
Yes.
And an example of that is Pinot.
An example of that is Pinot, yes.
But there are other ones.
Yeah, there's another Apache project called Druid is another example of a database that gets used for real-time analytics.
And so what would distinguish one from another? Like what would be a use case for each?
The use cases are really the same. They honestly compete for the same space. So they compete on, health of the community, performance. It's like how do databases fight? Databases fight on benchmarks. They fight on, which one has more people adopting the open source version. And I mean, let's not get into that in the stream, right?
Okay. So the point is to consume and store the data from all the Kafka topics in your system, right?
Yes, and deliver queries at scale with real-time latency characteristics, and I'll get to that in a minute. I'm seeing some questions. Is it okay if I just take them?
Yes.
Rick says, love this light board. You know what, Rick? Not a question, but I love it. You should say more things like that. How to run event-driven architecture on serverless. I kind of can't take that. That's just too big. Can you use Pinot and Pulsar? Yes, yes, yes. Just, there is no.
Can you tell me what Pulsar is, please?
Pulsar is a competitor for Kafka, a competitor with Kafka. It's another event logging, streaming, computation system.
Gotcha. So Thank you.
I mean, in the open source world, it's weird to say competitor, but I mean, you wouldn't use them both. You'd pick one.
Gotcha.
You definitely have an opinion when you're picking one over the other.
How do you run event-driven architecture on serverless?
your microservices are just going to have to respond to events in topics running in a serverless architecture rather than running as services that are, in some kind of container and running thread pools and so forth. So it just has to do with the way that you're deploying the services code.
When you said SQL Server, I'm sorry, were you not finished?
No, I was okay. About to read that question, and I realized, actually, this is your show, and you read the questions.
It's a team. It's a team effort. When you said SQL Server, did you mean to include SQL Server Analysis Services in that, or am I going in the wrong direction?
I didn't mean to say too much about the Microsoft OLAP stack because I don't know that much about it. So I think, Thindal, I think you're going in the right direction. At least I assume you are. I actually don't know much about the details there. I do happen to know that by market share, Microsoft owns the plurality share of OLAP. So they're the biggest slice in the pie. And they're not one of the cool kids. Like 0 people talk about them when they talk about what's up and coming in OLAP. They are printing money. So that was kind of where I was going. But I don't want to get into the details of their stuff because I don't know. But I sense you're going in the right direction.
Zyker says, OLAPs like Pinot are next level. They provide high queries per second at milliseconds latency.
What a great segue, because I wanted to start talking about that.
I guess I have a question. There's something maybe it's the processing. There's something I'm not quite getting, which is why can't they just consume from the topic immediately? Why does it need to be in a database?
Got it. Okay. Because services can consume from topics, have to consume from topics. The payment service needs to know what is the order that just got placed. I just need that order in front of me. I don't need to know anything about anything else. I just need this order. I am a function, and this is my parameter, and I'm going to go do work in the world. That's not what an OLAP query is. An OLAP query is what have people in the 80120 zip code ordered today? What have people around, Bellevue and Broadway, what have the delivery times for these 5 burger joints been to people around Bellevue and Broadway in the last minute? And by the way, that's changing by the second during a peak time. So those questions aren't give me this thing. Okay. The fundamental impulse of OLTP, someone had mentioned that it had to do with writing, and that's true. But the fundamental idea is, what is this thing? This order, this payment, this hamburger. It's always about a thing. The fundamental idea of OLAP is what's true about these things. I need to go through all the things and compute a summary, an average, a sum, a min, a max, some kind of aggregation over all these things. And that's a very kind of technology. And there are you are optimized to do one of those or the other. That's why there are OLAP data. And in the case of something like Pinot, it's optimized to do that. Not just to power a dashboard inside the business. In fact, let me actually, before I go, I want to make sure that was clear. Let me stop and make sure.
So what I'm hearing is you're processing how these streams all relate to each other instead of just picking up one thing from each stream.
Yes. What is the overall? That could be a combination of lots of streams. Certainly a combination of any events in one stream.
Yes. Over different time periods that are adjustable. Then just like it kind of seems like if it's all stored here, the world is your oyster even after it happens in terms of what you're querying. You can determine that in the moment. Where if that logic's written into your microservice, then that's harder to.
And after, in the case of the real-time stuff, after it can be yesterday, that's fine. I mean, it's not like yesterday is uninteresting. It's just that maybe the last 5 seconds are interesting. And we used to not have a way to deal with that. Thindal just asked a really good question that I want to wait. I want to keep pushing on why real-time analytics is a different thing, but we're going to get back to predictive logic when we get back to questions. That's a super good question. Now, The idea of OLAP is not new. Again, when I was a younger man, this was a brand new discipline, at least in the current state of things, was a brand new discipline. Yeah, queries per second. There you go. Thank you. But it was a batch process, and it was focused on a decision maker, a report, a printed report. This is the 90s, right? Laser printer. And in the morning, a fancy person in a suit in a corner office gets a printed report. Okay, this is what happened yesterday. And that's great. Again, that was huge. We're not necessarily just interested in that person. We still are. Like they still need reports, but increasingly we're finding in things like LinkedIn, Uber Eats, these are examples. We want to do roll-ups of events in the business and analysis, aggregation of events in the business, but to turn around and show them to users. Like in LinkedIn, who viewed my profile? Well, there are 67 people from the construction industry have viewed your profile in the last minute, or whatever. This particular smash burger, it's getting orders delivered in 32 minutes right now to people in your area. So it's not a dashboard. Dashboards are still great, but now user-facing analytics, that's a completely different game. Because there are literally orders of magnitude more users than there are business analysts inside the company. So we're increasing now in, just call that concurrency, number of concurrent queries.
Are we gonna, okay, so I'm gonna, instead of putting it down here, so here are some things it enables, because user-facing analytics.
User-facing, that's the key.
And what was the thing you just said?
I forget.
That's okay.
I was talking about LinkedIn and
that's okay. The chat will help us, or
Oh no, there was a thing in chat about predictive logic that we need to get to after this.
Okay.
So, a system that writes reports, if a query takes, say, 5 seconds to execute, that's okay. I could build a report. I mean, how fast do I need it? Or a dashboard. That's okay. And that's kind of the current generation of big data systems like Spark SQL and Trino and Presto and things like that. That's the kind of latency characteristic that they're geared around. It's the joke about Spark SQL is everything takes 5 seconds. If there's a petabyte of data, if there's 100 kilobytes of data, it still takes 5 seconds. And that's very, very powerful. And that was a huge innovation. But if you're trying to power features in an application and now say, decision makers aren't just people in fancy clothing and fancy offices. Decision makers are everybody who's holding a mobile device and using your app. We are all decision makers now. That kind of infrastructure built on top of this event-driven architecture, you're not going to be doing ETL. You're not going to be doing a batch process that extracts stuff and loads it. That just doesn't make any sense. You have to ingest it natively into this database that can now serve hundreds of thousands of queries per second, tens of milliseconds latency to be able to power user-facing things. So there's this marriage between event-driven architecture and real-time analytics.
Can you hear me now?
I didn't know that I lost you. I can hear you. Yes. I can hear you. Can you hear me?
I can hear. Let me just adjust my audio settings. All right. Sorry about that.
No problem.
All right. So, how about now?
I can hear you.
I'm wrestling with my, okay. So 100, I forget where I was at. Sorry about that.
100,000 queries per second, and let's say 50 millisecond query latencies.
I wonder.
50 millisecond queries.
I want this here instead. So this is more what it is, and this is what it enables.
Yeah.
Yeah. So I kind of am unclear about what goes where. And then what's the latency you said?
I mean, it's a SQL database, so it depends, but you can get things in the order of 50 milliseconds, the fast stuff.
Okay, 50 millisecond. What's the unit of measurement? Like, what's the 50
milliseconds per query?
Per
it's
query.
A query that, or you could, per query is good.
Great.
And freshness is the other thing. This is how this world, this new event-driven and real-time world differs from the old data at rest, batch mode, ETL world. You'll have freshness of less than a second. The thing happens in the world and it's queryable in under a second.
Freshness,
yes. Data is individually wrapped. Freshness. Yeah. So because you have always needed an analytics solution, transitioning to this event-driven world has implied a new set of challenges, and these, this new class of real-time OLAP database has emerged. And if we go back over to the purple diagram with the COVID virus, what this is doing is acknowledging that on top of Kafka, like Kafka's good at events, which work really well for microservices. Kafka has mechanisms. The Kafka ecosystem has mechanisms for, I'm going to say it in a fancy way, materializing the state of events. So Kafka people, I can build a K table and get the state of, what the current average order price is or something. I can do that. I could group by zip code and compute that. I can write Kafka Streams applications in the Confluent ecosystem. I can use KSQLDB for that. I can, in simple ways, aggregate the state of events and turn that log into a table. But it doesn't quite act like a general purpose database. It doesn't quite act like an infrastructure layer. So what's happening here is, on top of Kafka, we're moving up into that coronavirus. We're adding a layer of infrastructure on top of Kafka. In this case, I'm talking about Pinot. That's Pinot. So there's this big fuzzy area where we're having to code down into the infrastructure layer because we're not sure where it stops. We're not sure where our differentiated application code really stops, and infrastructure ought to be doing that work. So sometimes we overfunction and we go build infrastructure things where we shouldn't have. And so what's happening is, with the emergence of real-time analytics, we're getting clarity on what that infrastructure is. And so the fuzzy thing, the bottom part of the fuzzy thing, moves up. And on top of Kafka, we've got this solid database.
Okay. I see.
You get, the world is less fuzzy now.
If only it were less coronavirus-y.
I know. I mean, it's a little less coronavirus-y than it used to be.
Yeah. We'll take what we can get. Okay. So real-time.
Yeah.
Real-time OLAP like Pinot. So I think, and this is, I'm a little, speaking of fuzzy, I'm still a little fuzzy about the storing versus the processing and what's happening. Is the processing wrapped up in the database itself?
Depends what you mean by processing. There is definitely processing happening in the database. The processing of a transaction, the doing the work to satisfy the commitment of the business, that's all down in Kafka and the services. That is, and it's funny, we're kind of doing this different view, but that's in Kafka and that's in our application code. That's what should be in our application code. That's like the only thing our application code should be doing. Trying to figure out what's been true about events from yesterday, from 5 seconds ago, from a minute ago, all that kind of stuff. That's not application code. That's an infrastructure concern. And so Pinot shows up on the scene to be like good friends with Kafka and say, no, don't write that code. Use a SQL query, or write the code in SQL, I guess would be another way to put that. But that's the right language to do analytics queries in. You throw a SQL query at the database, and it has already ingested that. Basically, as soon as the event happened in Kafka, it's there in Pinot and it's queryable.
Okay. So that's where the logic, I guess when I was learning about Kafka, part of what was amazing about it is that it could do the analytics of such huge amounts of data in real time within Kafka. So I guess that's the core of what I'm trying to understand is when it's such huge amounts of data. Yeah.
And both these technologies are designed for scale. What I'm saying is for Kafka to do the analytics, there are times absolutely where it's 100% appropriate to hand code that in Kafka streams, and that's the only right thing to do. But that's like a card catalog with one index as a table, right? It's a table that has one index. What if I've got a field that's JSON and a field that's text and another field that's got like pre-computed aggregates of sales numbers that I want to build based on like a little materialized pivot table. It's an index. It's a specialized index that Pinot has that I can do that kind of thing. Where I've got pre-computed aggregates based on various dimensions. You don't want one key. You don't want one index. You want a table with lots of indexes. That's the missing piece of infrastructure that we've been trying to code our way down into. And now the tools and the databases like Pinot show up and say, in your event-driven architecture, you still need to ask questions, and they need to be questions that are true as of a second ago. And thank you. There's another point in chat just now. If you want to be able to write ad hoc queries against these tables, you need a database that does that. If you just need to be able to make up queries, that's the point I was trying to make about how many indexes does a K table have? It has one. That's not an ad hoc query. That's a key lookup. If you need to be able to query based on various indices that are different types of data indexed in different ways, that's a new layer of infrastructure. And we've been coding around that pain because this is a new thing and there's not a lot of awareness of it. So once you've got this glorious event-driven world, you're going to need this new layer of infrastructure. You're going to need to add one of these databases to the system at some point.
Excellent. Thank you so much I feel like that was a bit of a remedial question, but it was helping me form my mental model. I appreciate that. I've been a little avoiding chat only because I know you have a hard stop at noon, and I want to make sure that you say everything you need to.
I'm sort of done with the story here.
Okay.
So if you want to take some questions and close out, I'm good.
Before we dig in on the questions, I would like to make sure I've captured somewhere like the takeaways that you want people to leave with. What?
Got it. Okay.
Yeah. Let's
do some takeaways now.
Yeah.
First of all,
maybe this enables is kind of there, but I want a bigger picture takeaways.
Yeah. So that there are really two sides of the coin we've talked about. We've said event-driven architecture, and I haven't said this explicitly, but it's a better way to manage scale and complexity. Because we are all distributed systems developers now, and logs are how you rationalize things in a distributed system. So just build your services around logs. Skip the middle step and just get there.
Great. Okay.
And we are seeing a trend towards the need for analytics to be real time. So we need a new infrastructure layer to provide real-time analytics on top of our infrastructure, our event-driven systems. And that's a newer idea, honestly. That second idea is newer, and I think being debated more. Event-driven architecture was a new idea 5 years ago and is feeling more and more settled now. But it's a few businesses are saying, hey, wait a second. All of this data, we've been ETLing this data so that managers could look at it. Wow, if we unlocked that, exposed it to users, we could build stickier services that people found more valuable and had cooler features in them. But none of the existing technology was really able to get you there because it wasn't designed for the freshness and concurrency and latency that you need for user-facing stuff.
So in other event-driven architectures I've seen that include a data lake. This is a data lake. This is like a data lake, but generally that data lake isn't instantly queryable, and this is.
Yeah, it's only like a data lake in that it's a place where you put data. It's otherwise profoundly unlike a data lake, because a data lake, one of the ideas is we don't need to worry about structure. Let's just put things there, and we'll figure out schema later when we write our map reduce jobs or do whatever. That was the early days. Whatever evolved version of that we're doing. In Pinot, it's just a database. There are tables. You have schemas. There are columns with names and data types. Everything is structured. So yes, you have to make those schema decisions. So it's not like a data lake in that sense. You are making decisions about structure now. I think the lesson of data lakes has been maybe that was the right thing to do all along. And thinking about schema, you're going to do it at some point, so you might as well do it now. Kicking the can didn't seem like it worked. If everyone watching the stream will pardon me for that opinionated statement, but yeah, so it's different in that it's structured, and it's explicitly real time, and data lakes are explicitly not. That's the everything takes 5 or 10 seconds or longer world. And the reason, the powerful insight behind data lakes were that wow, you could query a petabyte of data in 10 seconds. That was the powerful stuff. So the high scale, but the systems were not designed around real-time latency. They were designed around scale only.
And this, I don't know a ton about the data world, but is it assumed that every data solution in a modern age is distributed?
Yes and no. I mean, like Postgres isn't. Postgres gets used all the time. Postgres is a single server. I mean, you can build clusters out of it, but the process is, it is not a distributed system. It's a database that runs on a machine.
Okay.
Any of the new ones, yes. Anything new.
So Pinot is distributed?
100%. Yeah, there are.
And can we assume any real-time analytics databases distributed?
To a first-order approximation, yes. So the other guys in the space, the ClickHouses, the Druids, the Rocksets, all those things are all distributed systems.
I'm going to put it on that. Do you feel like we captured all the takeaways?
The other takeaway, just the idea of freshness, latency, concurrency, those are the key requirements in the real-time world, in the user-facing world, that are poorly served by existing solutions. By the tools that grew up around reporting and dashboarding weren't designed for freshness, concurrency, and latency that you need for the user-facing world.
User-facing analytics. Cool. I'm thinking I would like you to look at the chat since you can access it and decide which questions to give your last bit of time and attention to, and I will be here to highlight them on the screen.
There was predictive logic. I want to take that question. Is that entirely in the app layer?
Can you tell me who said it, please?
That was Thindall. How about predictive logic? Is that entirely in the app layer? So Thindall, you know my whole thing about how this is the code that you should write. This is infrastructure. We've shifted our stack all around, so we don't really know where those boundaries are. There's this big fuzzy region. Some of it should definitely be infrastructure. And Pinot is going, yep, I'm infrastructure. And then there's this other stuff in here. Like, should that be infrastructure? Should we write that? and we're still in the position of like, if you want to do fraud detection or anomaly detection in general, you know, like you're writing that. Predictive analytics, you're writing that. Kind of seems to me like this work isn't of shrinking this. That work's not done. You got this new generation of real-time analytics databases here, real-time OLAP databases. What about those very common things that are just cookie cutter, right? Why isn't there a standard anomaly detection layer? Why isn't there a standard predictive layer on top of that? So it smells to me like people who are in this new business should be thinking about what's a layer up in the stack. So shameless plug. I mean, that'd be the kind of thing that we'd be up to, right? I mean, we care about Apache Pinot, and that's like, it's my job to make it famous. But other stuff in that stack, if you look at the startups in the space, you know, you would I think demand that they would be moving up that stack in ways like that.
I have a question. This seems like it could relate a lot to observability in a Kubernetes cluster. Is that
100%? 100%.
true?
Now,
Yeah.
The observability is a little bit different. Like, it's not. Can the real-time analytics databases do observability? Absolutely, of course. Observability is entirely internal facing. It's not an external function, but it is a real-time function. Like if you were to graph this, you know, this is real time and batch and external and internal. He says with 5 minutes to go. Observability is on the internal real-time quadrant. And Pinot is optimized for the real-time external quadrant.
Okay.
But once you've mastered real-time, it doesn't matter if it's internal. It works just fine. So you could, it's just a more specialized space, right? You got your like Datadogs of the world who are being a real-time analytics database, but extremely purpose-built and optimized for monitoring clusters and you know, for ops, you know, for the ops purpose. So I don't know that, you know, Datadog is trembling in fear because Apache Pinot is on the scene. I think they have a robust business, but there's going to be interaction and substitution along these boundaries in the next 5 years.
I feel there are more questions in the chat, so I'm not going to ask mine. I'm going to let some other people have turns. So
I have a hard stop because we could looking for questions. If we can use Kafka, can we use Kafka for file streaming? I'm going to say no. Could you figure out a way to? Yes, but generally it's for events, not for media. Usually we'll outbox pattern that, right? So you'll put your file in some blob store and then produce an event that refers to the thing being put in the blob store. What other type of actions have you seen microservices take when connected directly to Pinot? So that's somewhat contrary to the spirit of OLAP, right? If you're talking about actions that you're taking, is still in the transaction processing world. So that is more in, if you're looking at a real-time analytics computation on which an action will be taken by a service, that implies that the output of that analytics computation goes back into a Kafka topic and a service consumes it. That means you're in Kafka Streams or KSQL DB land. They are not general purpose OLAP databases. You will die trying to build a general purpose OLAP database out of them. But if you're trying to do something that a service is responding to, that happens to be an analytical calculation, that's still in your transaction processing loop. And so you're going to write that yourself. So Pinot consumes all this and makes it available as, you know, SQL queries to push into to push into front ends, not into servers doing processing. I feel, and I think, Robert, I think that's you. I feel like there's a longer discussion to have around that. And the answer I gave was too imprecise, but that's always the nature of streaming and conference questions. You kind of have to simplify.
And I have one quick question for the last one, because I don't see any more in the chat. Is what would be different characteristics for internal versus external that you'd be looking for in a database?
Generally, the internal analytics can be satisfied by databases with lower concurrent, that can't support as much concurrency. If you can handle tens or hundreds of concurrent queries, you can do internal facing analytics just fine. So you don't have to be optimized
so
for
the
the crazy
scale of it.
10 to the 5, kind of thing.
Got it.
You can just do 10, 100. And generally for internal facing stuff, we've been satisfied with less freshness too. Freshness has been minutes or hours.
Okay, that's very helpful.
And folks are talking about an unannounced source available thing Startree is working on called Third Eye. Don't know if I'm supposed to be talking about that in the stream, but y'all are in the comments. So Tyndall, when I was talking about moving up the stack, that's the anomaly. That's going to be Startree's answer to the anomaly detection thing, and it'll be released under a community license. Just watch this space.
Excellent. This has been so fun. Thank you so
Whitney,
much
I've had
for
a great
coming
time.
on.
Thank you.
Good.
I'm sorry
Wonderful.
we have to stop. It feels like there's more to talk about, but here we are.
It's the best problem to have, so I'm going to chalk it up to success. Yes.
Cool.
Thank you so much, everyone, for coming. Thank you, everyone who watches the recording. We appreciate you so much. Have a wonderful day.
All right.
Bye.